finding the right granularity of your tests can be quite helpful. So very, simplified example. Imagine system A sends a message to system B, also sends a message to system C, and system C sends a message to system D on my middle right. If you really want to write a test that covers it all, infrastructure-wise, you need to find a way to have all the systems up and running, right? Sure, that you can solve probably with some amazing DevOps engineer, you make it happen, great. But then as a developer of system A, and probably system A is developed by one team, system B is developed by another team, so on and so forth, because those are big, chunks of functionalities. As a developer from system A, you know nothing about system B. But if you want to really write a complex test, system B, you need to understand system B because you want system B to respond in a specific way, given a request you're going to make to it. So it is more complex from an infrastructure point of view, and from a testing point of view, you sort of start to have to open boxes. You don't know so much about them, and that's very hard. And second, your team is moving really fast, but you can also bet that the team that built system B is also running very fast. So it's likely that at some point system B will break, and their build will be crashing, and they will have to, fix their build. But as a team developing system A, you don't want, every time the team B makes a mistake that this affects your productivity, which is sort of what happens if, your integration tests truly depend on the real system B. So maybe a suggestion would be a lot of your tests, make them isolated, make them as big as possible within your system A, the system you have control, right? So you don't have to write unit tests, you can test large pieces of functionalities in your own system, but you can still mock system B, you can still mock system C. So in this sense, you still have control over your own test suite. B and C will never break you. And that gives you, good pre-merge tests. They run very fast. You can get good feedback, and people from other teams will not prevent you from working. Of course, in such a situation, I have to mention that if you're really doing this, at some point you will need either contract tests or integration tests to make sure that if system B evolves, your system can still talk to system B, and you both are speaking the same language, right? So there's no silver bullet, so to say, right? And I think my point here is you are going to have to make trade-offs to simplify the lives of your developers, your infrastructure, your productivity. And let me continue on this topic. Usually the biggest fight back I get from people when I say, maybe you don't need to test your flow with 30 other production systems altogether. The answer is, but I have to do it because the bugs that happen in production, they only happen when all those systems are running together. Unit tests don't catch those bugs, right? Which is sort of true. A lot of, the hard bugs, they happen when weird combinations of messages happen. For sure, that is certainly true. But what I want to mention here is two things. So the first one is the types of bugs that happen in production in such a weird corner case, 1 in a million times, situation in production. Even if you're writing integration tests, you will never catch those bugs because you're not that smart. You're a human, and you cannot really see so deep. People have been relying on AI, even before, LLMs and, the new fashion cool AI, people have been relying a lot on search-based algorithms and, intelligent techniques to explore weird combinations. In integration tests, the most you're going to be able to catch as a human writing a test would be, configuration errors. When you put everything together, does it go up or not? Contract problems, maybe you send a message to system B returns, stops working because someone made an API breaking change there. These type of stuff, sure, you can catch them via integration tests, but you're never going to catch that bug that happens if a message gets 10 milliseconds later than it should get to your system. So have that in mind when writing such an expensive test, that you'll be able to mostly, try to understand the category of bugs you as a person can catch via integration tests. Yeah. And second, don't underestimate the ability of simpler tests to catch bugs. The paper on my left, Simple Testing Can Prevent Most Critical Failures, it is a primer paper to read to convince people that don't believe in simple testing. And what the authors there did, they looked at very complex distributed systems. So think of Cassandra, Hadoop, Redis, and they looked at the bugs and they looked at the patches and they tried to understand sort of, could this bug be caught by, a very small simple test? And to their surprise, the answer was yes. A lot of bugs can be caught via simple testing, right? Because that's life. A lot of our bugs are, new pointer exceptions or, combinations of values we forgot to test that you could test, only with a few small subset of components in your system. You don't need the whole system to test something, right? At Agile, we have this sentence in our internal wiki that says, don't write an integration test that could have been a unit or a component test. Because simple tests can catch a lot of bugs as well. Now, testing the legacy. If you're working on a successful company, it is likely you have legacy to handle. How do you do this? First of all, I see people giving this suggestion. I've seen these in books from famous authors, and of course, books written 20 years ago, maybe that suggestion made more sense then, but now not so much. The suggestion is, if it's impossible to test, just refactor the code and then write a test for it. And I find this a very bad suggestion. Why is that? Because first of all, refactoring some legacy system to make sure it's more testable, it is a lot of work. It's hard, it's expensive, it's prone to bugs, right? Because of course, in practice, what prevents you from testing is not that you have, a 200 lines method that you can quickly break it down into smaller components, whatever, move to different classes and then get them tested separately. No, usually the technical debt is way more complicated. So these refactorings are never simple. Second, the legacy is full of code that you don't understand and you're refactoring it. How are you going to be sure that your refactored worked in first place if you don't have tests? How are you going to refactor such a probably core component of your application without tests? Also, in a lot of cases, if you're focusing on testing, refactoring is not your number one goal, right? Your goal is to write tests, not to refactor. In a lot of cases, the legacy system might suck, might have old decisions, but you can still maintain it. It still pays our bills. Why would you refactor something that is working just because of testing? I don't think that's a proper reason, right? So this idea that refactoring will come first, I don't believe in that. What do I believe? I believe that if you're in a legacy system and you want to write tests, you will have to write libraries or frameworks or scaffolding or something that will help people to test the legacy. Dive deep into the problem. What makes the legacy harder to be tested? Is it because it's hard to set the data up on the database? Is it because the system has lots of hard-coded IPs that are very hard to be replaced in real time so that you can simplify your testing and whatever, make an HTTP call locally? I don't know. Understand where the pain is, and then write a tool or do a very chirurgical refactoring on the code base just to tackle that problem. You're going to be way more successful, if you ask me, if you approach the problem like this. In practice, to be really honest, I feel like if you just go to the developer and say, the developer says to you, hey, help me test this, and then you say, just refactor your code, the developer will never do this because he or she is not crazy, right? They will not really refactor something that they know is very complex, that they understand very little, they know it's going to break. So A developer that understands about the legacy would never do this in any case. Legacy systems are also likely not to have good coverage or good test suites, and understanding what to test is a problem when you're there, right? Maybe you have millions of lines of code, a couple of hundreds of flows that you want to get tested, and if your mission is let's test it all, you're going to fail because that's too big of a mission. You got to focus. My suggestion is get together with this team and come up with a test plan. A test plan should be basically a list of things you want to get tested that are very, very important. A good definition for me of what a test plan is once you get this test plan done, you should feel comfortable in deploying that application, because if the tests are green, you're confident that the application works. Note that you don't need 100% coverage to get such a confidence, right? You can test a lot of stuff, you can leave a lot of stuff out and still be confident enough to push to production. So that's what a test plan should be. Help your people to prioritize what's important and what's not. From my experience at Agile, this is very hard. Even if you give this task to the team that is really working hard and for maybe years on that part of the legacy, they still don't have a lot of clarity on what needs to be tested. So involve developers, involve your senior engineers, your staff engineers, your product managers. Try to come up with this minimum viable test plan, and this is what you should focus on. Another suggestion, focus on business. Also another lesson learned from our initiative at Agile, that if you just give this task to the team, maybe they will approach it from a very technical point of view. For example, let's just get coverage in those 20 classes, and then a developer goes there, writes unit tests for those 20 classes, and in the end was like, okay, cool, that's very nice, 20 classes that are tested. But you don't know if the software still works, right? So what you want to really get tested is business. What are the 20, 30, 40 business flows that really truly matter in production, and those are the ones you want to get exercise. Code coverage can be a great tool to help you. I know a lot of people hate code coverage. I'm here to try to debunk this myth that code coverage is bad. Sure, code coverage can be tricked by people. It's easy to cheat the metric, but if you're using the metric with the right purpose, it can help you. How? Because if you look at coverage, it will, in a legacy system, it will quickly show which areas of the system are not tested at all, and that may help you prioritize. So you can combine your test plan that has a business focus with your code perspective and see, you combine both information to decide what to test. I don't want to dive into should we have quality gates that aim for coverage, so on and so forth. That's a different discussion. I'm open to discuss this in another moment. But let me just tell you that although we can track code coverage, there's a good amount of research that shows some interesting correlation between the coverage a test suite achieves and the number of bugs it can actually catch, right? Its effectiveness, how effective a test suite is, it is correlated to the coverage. That makes sense, right? A test suite that covers more is more likely to find a bug than a test suite that covers less. A test suite that has 90% coverage, supposing you wrote good tests, is much better than a test suite that covers 20%, even if this test suite was also written in a proper way, because you're just covering more. So the lesson learned here is maybe 100% coverage doesn't say much. You can still have bugs, of course, but very low coverage says a lot, right? Says you don't have tests, and then you have to work on it. If you're going through a very large testing transformation, you might need some allies. You alone is just one person, and there's an army of hundreds of people that you have to convince to change their mindset. So you need allies, you need champions, evangelists that can help you pass the message that testing is important. So at Agile, at the very beginning, when we started to push for more tests, we decided to assign a test champion per team. And the test champion would be the point of contact to my team. So this would be the person who is sort of held accountable for the test plan, but also the person has the internal mission to talk to their team members about, hey, we need to get better testing because we're not doing so well here, and there, right? So as soon as you have a life in the teams, it's much easier. It's much easier for, psychological behavior. It's much easier for you to be convinced by someone that you work every day together and you have lunch every day together than by a stranger, between quotes, a person working for a platform team that may not truly, fully understand your context. So, lesson, look for champions to help you on this mission of scaling testing. Tracking progress, organization, what do you need from your organization? So if you're going through this large transformation, you surely will need the company's buy-in. It is very hard to do big initiatives in a bottom-up manner, right? The top needs to support, because at the end of the day, it's all about priorities, right? And the teams are not slacking all day long. They are building stuff. They're building actually the features that pay our salaries. So they have a lot of things they need to do. And then if you say, hey, you also need to, write lots of tests now, put this in your backlog, of course, this will have less priority if they don't have a lot of support to understand the need. And if there's no top-down message saying, folks, reliability, quality is key for us, we gotta change the way we're approaching quality. So try to get the company's buy-in. One challenge in there is that testing in general is something that only pays off at medium and long term. In short term, it's very hard to see benefits. Imagine you have like 2% coverage in a module that is super important, and the developer spends the day, and then she moves the needle from 2% to 2.5%. She wrote 10, 15 tests in a day. What difference does this make? Probably very small in comparison to the whole. It needs a lot of testing until this starts to pay back, right? Until those tests start to break in the pre-merge and the developer's like, aha, this test really caught a bug, right? So you got to explain to people that this is not going to be something you are going to improve, change in a week. It is going to take time. It is sort of an investment you have to do, and maybe if you took too long to start this, it might cost you more. But I promise you, once you're there and you have a good test suite, life will be so much better. Tracking is very important, so you can understand which teams are doing good, which teams are not doing so well, so you can enable them even more. Things you can track: coverage, completeness of the test plans. You can put some business perspective / architectural concerns on this. Like, for example, if you have a lot of jobs and endpoints, you can measure how many of those are covered and track these over weeks to see if people are improving. So measuring is also very important to understand if your initiatives, if your ideas are paying off, right? Traceability matrix, this is something we recently introduced. That is, we let product managers to write the most important flows in a tool, and then these flows are then linked to automated tests, and then we can easily see if those tests for those flows are green or not. So it really helps you to track important business flows written by a business analyst, product manager, whatever you call in your company, to automated tests. Beyond testing is just a start. Right? If you're walking this reliability lane, you also need to think a lot about monitoring, right? So you need to work on observability, alerting, SLOs, right? Because testing focuses a lot on, before we get to production. But it doesn't matter how much effort you put. In large, complex systems, you still will have bugs. They are unavoidable, unfortunately, or at least, up to the knowledge we have today. So what you do is, okay, you assume you're going to have bugs, but you want to be sort of the first one to know you have bugs, right? So you need proper observability. You need alerting, so people get notified when something happens. You need SLOs to understand how you're doing, and if you're breaching any of your contracts, for example. The possibility of doing partial rollouts is also very important. In large scale systems, maybe you don't want to push a feature to production to 100% of your user base, because if there's a bug, this affects everyone. So you want to have the ability of pushing the feature to like 1% of your user base, and then you monitor, then 2, 5, 10, whatever your thresholds are. So you slowly build trust that your code works in production until you open. And this is really important, because if you start to see like this is crashing, you can, at a click of a button, disable the feature, and then the bug stops. You're still, of course, back to the old version of the feature, but it's a working version of the feature, and maybe that's better than a broken version of the feature, right? Especially for us in the payments domain, we don't want to reject payments because of a bug. You want to have a great continuous integration, continuous deployment pipeline. So from a deployment perspective, if it's easy for the team to deploy, that's great, because you approach problems in a different way. There's a problem in production, you get information because your observability is great. You patch, you deploy, in a couple of minutes, the patch is in production and this bug is not there anymore. So automate your deployment as much as you can. From a CI perspective, you want to give good signals to people that their code is working, right? So you want to make sure that you can run all their tests, that you can run all their post-merge tests, that you give them decent information if a test breaks. Maybe you want to have static analysis to complement for things that people are not so good at testing. And whatever other checks you feel like you can automate to help people understand if they wrote something broken or not. Yeah? Cool. So that was my talk. I spoke a lot and very fast because I wanted to cover so many different topics. So we spoke about how to scale testing from a perspective of making sure the organization, all developers are writing lots and lots of tests every day. We spoke about testing legacy and how some existing advice is not so good. So focus on finding a way to test the code as is, come up with a test plan, track. Organization-wise, we said that you need top-down support so you can do the real transformation. And testing is only the first step of your journey. Your journey towards reliability should not stop there. I hope you enjoyed my talk. I hope you learned something. I'm always open for comments and feedback. Drop me a message on Twitter or on my email. That's my website. See you soon.